So my function here is f of x equals e to the 4 minus x squared. And I found the first derivative of that first, which is negative 2x times e to the 4 minus x squared, which I then set to 0. So then I would have to get negative 2x to equal 0, so x equals 0, which is my critical point. So since that's my critical point, I need to find out whether it's increasing or decreasing here. So I have a negative 1 plugged in, which would give me a positive times a positive, so that means it's increasing. And then on the other side, I have a 1 plugged in, and I have a positive times a negative, which gives me a decrease. So here I just plugged in x equals 0 as my critical point, which gave me a y value of 54.6. And then I just wrote down the intervals where it's increasing, which is negative infinity to 0, and the interval where it's decreasing, which is 0 to infinity. And next I found the second derivative to find where it's concave up, concave down. And this is like a really long second derivative, negative 2x e to the 4 minus x squared times negative 2x plus e to the 4 minus x squared times negative 2. So I simplified that. I took out e to the 4 minus x squared, and then that left me with 4x squared minus 2 here, which equals 0, because I want to find where it's concave. And so that gave me 4x squared equals 2, x squared equals 1/2, and x equals plus or minus 0.7071. Let's see if this will work. Cool. So after I got those values, I then plugged in a negative 1, 0.5, and 1, which gave me here a positive, negative, positive, which gives me concave up, concave down, concave up. So then I just wrote down the intervals where I had concave up, which is negative infinity to negative 0.7071, as well as 0.7071 to infinity. And then for concave down, I got negative 0.7071 to 0.7071. So now I have like the little details here to fill in the rest of the graph. So I have the domain of negative infinity to infinity, because you can plug in anything really. And then the end behavior as x approaches positive infinity, y is going to equal 0, and as x approaches negative infinity, y is also going to equal 0, because that's how the e-graph looks. So my relative max from before is 0 and 54.6, that was my critical point where it went from up to down. And then my y-intercept is 0 and 54.6. My symmetry gave me even. And those are just my inflection points where it went from concave up to concave down, which I just plugged in the where it turned, see right here, from positive, negative, negative to positive. I plugged that into the original. And after that, here's my graph. Excuse that blemish here, but you know, the symmetry, the y value, which is also my critical point, my relative max, and then these right here, you can't really see them very well, are my inflection points. And that is how you graph this function of, what was it? E to the 4 minus x squared.